this video, we're talking about long division of multivariable polynomials. We've already learned how to do long division with whole numbers, and we've learned how to do long division with single variable functions where we were just given a fraction where we had only an x variable in the numerator and only an x variable in the denominator. But now we have two variables in both the numerator and the denominator. We have x and y. And when that's the case, we can still do long division with polynomials. It's just a little bit trickier. So as always, the same as before, we take the numerator and that becomes the dividend. That's what we put inside our long division bracket. So we're going to do x cubed, but then we're going to leave some space and we're going to put over here minus y cubed. And you'll see in a second why we're going to need that space. And then we're going to divide this by the divisor, which is always the denominator. That's going to be x minus y. And now we just proceed as usual. So we have to figure out what do we have to multiply by x to get x cubed, or how many times does x go into x cubed? Well, that's going to be x squared because x times x squared gives us x cubed. So we have x squared. Now we're going to take x squared and multiply through by the entire divisor. So x squared times x is going to give us x cubed. And then x squared times a negative y is going to be a negative x squared y. Now, as always, we're going to subtract our result. We want to subtract x cubed minus x squared y from x cubed. However, as you can see, we're going to need an x squared y term, and we don't have one. We only have this negative y cubed, but we can't subtract negative x squared y from negative y cubed because they're not like terms. So what we'll do is we'll go ahead and add in a 0 x squared y like this, so we can subtract x squared y from 0 x squared y. So when we subtract, we always just change the signs. So we'll say minus and plus to subtract, and then we can add. So change the signs and add. X cubed plus a negative x cubed is 0, so those two cancel. 0 x squared y plus x squared y is a single x squared y. And now we need to figure out what we have to multiply by x to get x squared y. Well, of course, that would just be xy. So we go ahead and say plus xy, and now we multiply xy through by our entire divisor. Xy times x is x squared y, and then xy times a negative y gives us a negative xy squared. We're going to need an xy squared term, so we want to say plus 0xy squared, and we want to go ahead and bring this down. So we'll say plus 0xy squared, and then we want to subtract here, so we're going to change our signs, and then we're going to add. X squared y plus a negative x squared y is 0. Those will cancel. 0xy squared plus xy squared is a single xy squared. Now we need to figure out what we have to multiply by x to get xy squared. That's just a y squared. So we'll say plus y squared. Now we multiply y squared by the whole divisor. Y squared times x is an xy squared, and y squared times a negative y is a negative y cubed. Now we need a y cubed term. Fortunately, we already have it. We always have to remember that we have this term hanging out here. So now instead of adding a term in between, we can bring this one down. So we have a negative y cubed. This comes down to here. So the point being, of course, that whenever you get to the term that matches this one up here, when you get to a like term, you want to go ahead and bring this down. But as long as they're not like terms, you want to continue adding these 0 terms in between. So we bring this like term down. Now we need to subtract here, so we'll change our signs and then add. So xy squared minus xy squared or plus a negative xy squared is 0. They cancel. Negative y cubed plus y cubed is 0. So we finally got into a 0 remainder. So we know that we're done, and we can say now that x cubed minus y cubed divided by x minus y is equal to the quotient that we found here, x squared plus xy plus y squared. And remember, if you want to double check yourself, you can just multiply the quotient you found by the original divisor or the original denominator from our fraction. And if you FOIL this back out, if you multiply everything, you should get back to your original numerator, x cubed minus y cubed. So that's how you use long division to find the quotient of two multivariable polynomials.